Slope-intercept form. Slope-intercept form is a way to write an equation of a line where the slope and the y-intercept are easy to find and plug in. Every line can have an equation written in slope-intercept form. Slope-intercept form is y equals mx plus b. Y and x are going to be your variables, which would create an ordered pair, which is a point on the line. The m is going to be the slope, and the b is the y-intercept. These next examples are going to give you an equation in slope-intercept form, and it asks you to identify the slope and the y-intercept of the equation. So this equation is y equals negative 7x minus 10. The slope would be negative 7, and the y-intercept would be negative 10. Notice that in both of these cases, these are negatives. I'm keeping the sign that is in front of the number. This next equation is y equals 4x plus 9. The slope would be 4. The y-intercept would be a positive 9. The next equation is y equals 1/2 x plus 9. The slope in this case is 1/2, and the y-intercept is a positive 9. Notice that when I am saying the slope, I am not including x with the slope. X is not part of the slope, but x is what is being multiplied by the slope. So we can identify the slope as the number that is being multiplied by x. But x is not an actual part of the slope. It's just the number in front of it. This next example, we have y equals negative 7/8x. The slope in this case is negative 7/8. We are not adding or subtracting anything, but not adding or subtracting anything is the same as adding or subtracting 0. So when there's just a number times x, my y-intercept is 0. Notice that does not mean that there is no y-intercept. That means that the y-intercept is at 0. The next example, we have y equals negative x plus 9. In this case, my slope should be a number in front of x. There is no number there, but remember, in front of every variable, there's always an understood 1. So my slope would be considered negative 1, and my y-intercept is 9. These next examples ask me to write an equation given the slope and y-intercept. Remember, the slope is m and the y-intercept is b. So to write an equation with a slope of 6 and a y-intercept of negative 5, I'm going to plug in 6 for m and negative 5 for b. So the equation would be y equals 6x minus 5. The next example, I'm going to plug in negative 1 for m and 0 for b. So my equation would be y equals negative 1x plus 0. If you remember, plus 0 or adding 0 is not going to change whatever negative 1 times x is, so it is not necessary. As well as, I don't have to write a 1 in front of a variable if there's just one of them. So actually this equation y equals negative 1x plus 0 could be written as just y equals negative x. In the next example, it tells me that my slope is 0 and my y-intercept is 9. When I plug in 0 for m and 9 for b, I get y equals 0x plus 9. Even though I don't know what x is, 0 times x we know is 0. So writing 0 times x is not necessary. I can rewrite this equation as just y equals 9. And the last example, it tells me I have a slope of 6 over 11 and a y-intercept of negative 3. When I plug in 6 over 11 and negative 3, I get y equals 6 over 11x minus 13. I need to find the slope and the y-intercept of this line, and then I want to write the equation of this line in slope-intercept form. Remember, to find the slope of a line, I count from one ordered pair to the next the rise over the run. Choose 2 points on this graph and count rise over run. I'm going to go from this point, and I need to go down 2. When I move down, remember that's a negative, so my rise would be a negative 2, and then I need to move to the right 3. So my slope for this line would be negative 2 over 3. Depending on what point you chose to start at, you might have a slope of a positive 2 over a negative 3. That is going to be okay. That's the same thing as a negative 2 over a positive 3. In this case, my y-intercept is on the y-axis at 1. So when I use the slope and the y-intercept to write an equation of this line, it would be y equals negative 2/3 x plus 1. The next example, we're given this line. Again, they want us to write an equation in slope-intercept form. The 2 things that I need to write this equation are the slope and the y-intercept. I'm going to go ahead and count the slope on my graph. At whatever 2 points you choose, you count. We should end up with the same thing. I'm going to count up 5 from the point furthest to the left, and then I need to go to the right 1. So my rise would be 5, and my run would be 1. So I have 5 over 1. Remember, if you can write your slope as a whole number, you do want to go ahead and do that. So if I have a slope of 5 over 1, that's the same as having a slope of 5. In this case, my y-intercept, the point where this line crosses the y-axis, is at 0. When I write this equation, I'm going to have y equals 5x, and I do not need to put plus 0 because adding 0 does not change the value of a number. The next example, we need to find the slope and the y-intercept of this line. When I find the slope, I need to move down 1, so my rise would be a negative 1. And then I need to move to the right 4, so my run would be a positive 4. So my slope is a negative 1 over 4. The y-intercept of this line is at negative 4. When I use the slope and the y-intercept to write the equation of a line in slope-intercept form, I get y equals negative 1/4 x minus 4.